Hey class, today we're doing something really fun. We're going to find volume of three-dimensional objects that are being spun about axes. Super exciting stuff, building off of the area under the curve that we already know how to find. So make sure that you print out your 6.2a notes and let's get started. So if we were to graph y equals square root of x, it would look like this first graph on the left. And then imagine that we were spinning it. I'll draw a little spin arrow about the x-axis. It would look like this. So of course, if I wanted to see how much volume that would actually hold, I could imagine that it was nothing but a bunch of circular discs that were all lined up just like this one. Only every disc would not be the same size. So I would have to find the area of each of those discs and then add them all up. Now, you probably remember from geometry and perhaps algebra 2 that when you found the volume of a cylinder, it was pi r squared h. And so we're going to use that volume of a cylinder But in this cylinder, these radii that we were looking at, remember that I would only need half of that for a radius. So there's my radius. So they're the height of my rectangle. And our height is the thickness of our disk, but we would assume that we would make all the disks the same thickness. So they're just going to be a delta x, or of course dx. So some important things to keep in mind is what our spin axis looks like. So in this particular case, we have a horizontal spin axis, which tells us that we want to integrate with respect to dx, which means I would like my equations to be in y equals. And I currently have y equals the square root of x and the x-axis, which is y equals 0. So the first thing I do is I connect and make radii perpendicular to the spin axis. So that way I can see which two equations are touching to form my radius. And I'm going to write my radius. Just as though I were finding area, I'm doing top curve, which is square root of x, minus the bottom curve, which is 0. And of course that simplifies to just square root of x. So I'm ready to find my volume. And I'll do this by integrating to find the area under the curve times the height. So my formula now looks like this. I brought the pi out in front since it's just a constant. And my radius is square root of x, so I will square that. And my height, remember, is just dx. Now, the leftmost radius, it can get down as small as 0, and the rightmost radius can get as large as 4. So I'm integrating, or it's bounded by 4. So the leftmost radius can go to 0, the rightmost radius can go to 4. So my boundaries for my integration are 0 to 4. And now, when I integrate, I get pi times x squared over 2, and I'm substituting in 4 first, so I'll get 8 pi minus 0, or just 8 pi. So let's do the next one, and of course the first thing I want to do is I want to graph it. And if I solve this equation for y, I'll end up with y equals 1 over x squared. And this generates two equations, y equals 1 and y equals 4,